All right, ladies and gentlemen, welcome to today's video lesson for trigonometry. And we're going to talk about a couple of topics today. More specifically, we're going to find reference angles of measurements that are given to us in radians. We're also going to evaluate trigonometric functions using radians as well. Yesterday, what we did was I gave you guys a bit of an introduction to this topic, and I made reference to a table in your textbooks that is found on page 119. And in that reference angle, and in that table, they give us the values of the sine and the cosine of certain angles in trigonometric form. So, for example, if I were to say find the value of the sine of pi over 6, and I wanted you guys to find the measurement in degrees. You know that you would convert that by utilizing the formula 180 divided by pi, whereas I would simply just cancel the pi functions, and I know that 180 divided by 6 equals 30. So I know that pi over 6, or pi sixths, equals or is equivalent to 30 degrees. Now, in the first example that we're going to see in today's lesson, they're asking us to find the value of the trigonometric function using radians. So the value of the exact value of trigonometric function. So we did this in our previous lessons by memorizing or going over the angles of special right triangles. For example, if I had excuse me for a second, ladies and gentlemen, seem to have had a technical malfunction. So give me 1 second and I will reacclimate myself again. Give me 1 second, ladies and gentlemen. Okay, so as I was saying, we know for a fact that and if I were to ask you to find the sine of 30 degrees, you would say, well, the sine of 30 degrees is 1/2 because it's a special right triangle, or it's a special right angle. Likewise, if I were to say find the sine of 45 degrees, you would say that's the square root of 2 over 2. So what we did last semester, towards the end, is we found the trigonometric functions or trigonometric values of these functions in degrees. Today, we're actually going to evaluate trigonometric functions for angles in radian measures. So if I want you to find the exact value or evaluate the sine of pi thirds, I actually want you to find the sine of pi thirds. Now, you can do it in two ways. You can memorize the values that are in the table on page 119, in which the angle measurements of the sine are given to us, or we can utilize the method that we have practiced so far, which is to just convert the angles into degrees. So either way, you're going to see that the answer is going to be the same. So let's say that you're still having a little bit of trouble and you haven't quite memorized the values in the table on page 119. You still have the option of actually converting this into an angle and then just working with that. So let's say, well, actually not approximate. Let me erase that. Let's say that I want to convert the angle pi thirds into an angle. So I would just say that pi thirds, if I want to convert this to an angle, equals the same thing as saying 180, or I multiply this by 180 over pi, like we did in our previous lessons. And I know that a lot of you are having or don't have any issues with that. So 180 over pi the pi symbols cancel out, and then you would have 180 over 3, which is 60. So I know that pi thirds is equivalent to 60 degrees. So that means that the sine of 60 degrees will also equal the sine of pi thirds. And we've noticed, or we know by now, because we worked on it for so long, that the sine of 60 degrees is actually the square root of 3 over 2. So the sine of 60 degrees, sine of 60, the sine of pi thirds, let me write it down here, is equal to the sine of 60. So the sine of 60 and the sine of pi thirds, like I mentioned, is the square root of 3 over 2. And that's pretty much how you would do it. I mean, if you know the values, if you've memorized the values, you really don't need to do a lot of the procedure. However, if it's still something that is it's new to you, or you quite haven't been able to memorize them all, then you can just use this method. Remember, again, the sine of pi thirds equals the sine of 60, and the sine of 60 is the square root of 3 over 2. So let's look at one more. Let's say I want you to evaluate the cosine of pi thirds. Now, instead of the sine of pi thirds, we're going to look for the cosine of pi thirds. So again, assuming, let's assume that you don't know the value of any of this. Let's assume that you don't know the value of any of this. And I'm actually going to go it, right? Let's assume you don't know the value of any of this. Let's assume that, excuse me. Let me erase this. And let me erase this line. And let me erase this. So now we're looking for the cosine of pi thirds. And let's assume we didn't do the sine, and we're still haven't memorized the table. So we do the same thing. We use the formula. We say that pi thirds equals 180 over pi. And we simply cross cancel pi and pi. And that would leave with 180 over 3. And we know that 180 over 3 is 60. And we already know that, right? I mean, pretend you didn't see the last example. We know that the cosine of pi, or that pi thirds, equals 60 degrees. And that also means that whatever the cosine of pi thirds is equal to the cosine of 60. And since we've worked with special right angles before, and we know that if the sine of 60 was the square root of 3 over 2, then the cosine of 60 equals 1/2. So the cosine of pi equals the cosine of 60, which equals 1/2. So that's pretty simple. That's how you would find or evaluate a trigonometric function using radians. Using radians and for special angles. Now, let's look at reference angles. So we have discussed reference angles before, and we know that whenever we're looking for reference angles, we have to use the quadrants. So this is what I mean. Let me go ahead and clarify all this. So we know that whenever we're evaluating trigonometric functions in a coordinate plane, that's divided in quadrant 1, 2, 3, and 4. Remember that a positive rotation is counterclockwise. 3 and 4. 1, 2, 3, and 4. And what that's going to do, and we also determined that to find the reference angles in degrees, or the terminal side, we had formulas. And we know that, for example, if we were going to find in quadrant 1, alpha would equal the value of theta because it's in quadrant 1. And if we were looking for reference angles in quadrant 2, the formula that we would be using would be alpha equals 180 over, we would say that alpha equals 180 minus theta. So we would say 180 minus theta. And if it was in quadrant 3, it would be theta minus 180. So quadrant 3, which quadrant 3 we would say would be theta minus, or alpha would equal, alpha would equal theta minus 180. Theta would equal, or alpha would equal theta, whatever the value of theta is, minus 180. And if it's in quadrant 4, we would say and that alpha would equal, and this is of course in degrees, alpha would equal 360 minus theta. Minus theta. Okay, so that's in degrees. If we had the measurements in radians, we would say that in quadrant 1, alpha would continue to equal the value of theta. That wouldn't change. But if we were working in radians, in quadrant 2, we know that we would say, well, 180 minus theta. But in radians, 180 is pi. So we would simply say pi minus theta. In the value in quadrant 3, we would simply say that alpha would be theta minus pi instead of theta minus 180. And of course, if it was in quadrant 4, we would say that it would be 2 pi, because 360 is equivalent to 2 times pi, minus the value of theta. Of course, assuming that theta, in this case, is given to us in radians. So this is how you would calculate the reference angles of a measurement given to us in radians. So let's look at example number 8. And example number 8 says finding reference angles. It says find the reference angle for each angle given. So we're going to find the reference angle of 3 pi over 4 and 11 pi over 6. Now there is a trick that we can use for finding reference angles given to us in radians when, for example, the radian measurement is equivalent to a special angle. And let me explain this real quick. So if we look at the radians of special angles, we know that, for example, we have pi or 0, excuse me. And this is also the table on page 119. 0 equals 0. Or rather 0 pi 6. Just like we have special angles, we have special radians. So we have 0, we have pi 6th, we have pi 4ths. We have pi thirds, or pi over 3. And these are special radian measurements, so pi over 3. And we have pi halves, and we have pi. And so let's just write that down here. Pi halves are pi over 2. And we have pi. And we have 3 pi over 2 and 2 pi. So I'm going to write that down here and see where I can write that. I think I can manage it down here. Actually, 3 pi over 2 and of course we have 2 pi. And each one of those radians also has a special angle. We know that pi over 6 is 30 degrees. And I know that this sounds a little long and tedious, but it's going to make sense in just a minute when we go to the examples. And we know that pi fourth is 45 degrees. And we know that this is 60 degrees. And we know that pi over 2 is 90 degrees. And we know that this is 180 degrees. .270 degrees would be 3 pi over 2 is 270. And 2 pi is 360. So we know that there are radians, special radians, and those special radians have special angles. And we know, for example, the sine and cosine of each one because we worked on them before. Let me actually write this down here. So if we're being asked to find the reference angle of 3 pi over 4, having that knowledge is really easy because your book uses a procedure, but there's also a shorter method of doing it. And in my opinion, an easier way to understand it. Not saying that the method in the book is wrong. It's actually correct. The way your book does it is they look for the terminal side of the angle, and then based on that, they will execute the operations. But if we have, or we're being asked to find a reference angle of 2 radian measures where we could call it the base, although I'm not sure that's the right name, is a special angle. For example, if we look at 3 pi over 4, or 3 pi fourths, excuse me, we can see that pi fourths is a special angle. And right here, we know that pi fourths equals 45, although we're not really going to use the degrees. I just wrote them so that we can make an association. I know that pi fourths is an angle, is a special radian measurement. So if I'm being asked to find the reference angle of 3 pi over 4, because pi fourths is a special angle, I can simply say that the reference angle is pi fourths. And that's it. I don't really need to know anything else because, again, the reference angle is pi fourths. If I were to do the same thing here, I have 11 pi over 6. And again, I'm being asked to find the reference angle of 11 pi over 6. And I know that pi over 6 is a special radian angle. And I know that pi 6 is the basis of this measurement. So I say that the reference angle is pi over 6. I don't really need to do anything else. Now, granted, and it's very important to note that this will only work if the radian measure that is being given to me has a special angle or a special radian angle as a base. In a minute, we're going to see what would happen if we had a radian measure that didn't have a special angle as a base. Let's look at one more example. Let's say I want you guys to find the reference angle of 5 pi thirds. So let's say we want to find the reference angle of 5 pi over 3. So let me go ahead and erase this. 5 pi over 3. And then we'll see what we do when we have a measurement that does not have 5 pi over 3, that does not have a special radian as its base. So if I'm being asked to find the angle measurement, or the reference angle, the reference. If I'm being asked to find the reference angle of 5 pi over 3, because pi over 3 is a special radian angle, I know that the reference angle then is pi over 3, or pi thirds. Again, this method is only useful when the reference angle that I am being given or being asked to find has a special reference angle. But what if it doesn't? And that's what we're going to look at now. So I'm going to go ahead and erase this, and I'm going to look for an example where you're being asked to find a reference angle, but the reference angle is not a special angle. Okay, so what if we did that? Give me 1 second. Hopefully, the ad will pass on. So give me 1 second real quick. And okay, so what if I'm being asked to find the measurement of 3 pi over 5? So 3 pi over 5 does not have a special angle as my base. And because 3 pi over 5 does not have a special angle as my base, that means that I have to find a different method. I have pi 6, I have pi fourths, I have pi thirds, I have pi over 2, I have 3 pi over 2, and I have 2 pi, but I do not have 3 pi over 5. So what I'm going to do is actually first change this to an angle. And I do that by simply saying, 180 over pi. So I'm going to change the 3 pi over 5th into an angle. And I'm going to say 180 over pi. And what you're going to do then is you're simply going to cancel out the pi's. And that would be 180 times 3 divided by 5. So if you multiply 180 times 3, that would be 540. And divided by 5, and that would be 108. So I know that it's 108 degrees. So 108 degrees would be in quadrant 2, because remember, quadrant 1, this is 90, this is 180. So if I have a reference angle that is in 180 degrees, what I do according to the formula is subtract 180 minus the value of theta. So 180 minus the value of theta in this case would be 108. So you're going to subtract 180 minus 108. And that would be 72 degrees. So I know that the value of theta is 72 degrees. However, or that the reference angle would be 72 degrees. However, I want this given to me in radians. So that means that my last step is to take the 72 and convert it into a radian. And I know that if I'm going from degrees to radians, it would be pi over 180. So I multiply 72 times pi and then reduce my fraction. So 72 times pi is 72 pi over 180. And what I do now is I simply find a number that I can divide 180 by, that I can also divide 72 by. So going over the divisibility rules, I can simply divide by 2, or I can divide by 5s. But in this case, what I'm going to do is I'm going to look and go over my divisibility rules. And if I add 7 and 2, I get 9. And if I add 1 plus 8 plus 0, that would also be 9. And 9 is divisible by 9. So let me go ahead and explain that again. So if I want to reduce this fraction and I have numbers that are really not that, you can't tell right away what to do, we use the divisibility rules. Now we know that we can divide 72 and 180 by 2 because both of the last numbers are even. However, that would still give me a pretty big number, and I want to leave my answer as simplified as I can. So what I do after that is, what I do instead of that is I can use the divisibility rule. So I can divide by 2, but 2 would still give me a large number. If I add them, and I get a number that is divisible by 6, I could do it, or by 3, I could do it. So I could also divide by 3. So if I add 7 plus 2, that would be 9, and 1 plus 8 plus 0 would be 9. So technically, I can divide this number by 2, and I can divide it by 3 because 9 is divisible by 3, or 9 is a factor of 3. If I can divide it by 2, I can divide it by 3, or I can divide it by 9 because, again, if I add 7 plus 2, that is 9, and 180 would be 1 plus 8 is 9, and 9 plus 0 is 9. So in a nutshell, what I'm trying to say is that I can divide 72 by 9, and 72 divided by 9 is 8 pi. And I can also divide 180 by 9. I can also divide 180 by 9, and that would equal to 20. And I can actually divide this more, and I can divide 8 by 4, which is 2 pi, and I can divide 20 by 4, which is 5. So that means that my reference angle would be 2 pi over 5. And that's how you would find a reference angle if the base of the radian was not a special angle. So let me refresh that, or go over that real quick with you guys. 3 pi over 5, it doesn't have a special angle, so I can't use the method I did prior. So what I do is I convert this radians to degrees by multiplying by 180. The pi signs cancel out, and then I multiply 3 times 180, which is 540, and 540 divided by 5 is 108. So I know that the 3 pi over 5 is 108 degrees. And now I go make reference to these formulas, and I find that 108 degrees is in quadrant 2. So if I want to find the reference angle for quadrant 2, I simply subtract 180 minus theta, which in this case is 108. 180 minus 108 is 72. So I have my reference angle, but I don't want it in degrees. I want it in radians. So what I do now is I simply convert 72 degrees into radians. So 72 times pi is 72 pi over 180. Then what I did is I reduced the fraction, first dividing by 9, because 72 divides by 9 and 180 divides by 9, and that was equal to 8 pi over 20. Then, because 8 and 20, since I can reduce this fraction as well, I divide 8 by 4, which is 2, 20 by 4, which is 5, which means that the reference angle in that case is 2 pi over 5. Now, going back to example number 9, which would be the last example of this section, what you're going to do is, now understanding the concepts of reference angle, what we're going to do is evaluate a trigonometric function using reference angles. So in example number 9, if you have, I want you to find the cosine of 5 pi over 4. So let's look for the cosine of 5 pi over 4. And the first thing we're going to do is determine the reference angle. Okay, so let's look at that real quick. 5 pi over 4. So if I'm looking for the cosine of 5 pi over 4, the first thing I want to do is find my reference angle. And the first thing I want to observe to see if that's possible is the base of the radian, which is pi over 4. Is pi over 4 a special radian angle or a special radian measurement? And yes, it is. So that means that the reference angle of 5 pi over 4 equals pi over 4. And because pi over 4 is a special radian measurement, I know the cosine of it, because I know that pi over 4 is the same thing as saying 45 degrees. So in reality, I am looking for the cosine of 45 degrees, or excuse me, I'm looking for the cosine of pi over 4. And the cosine of pi over 4 is the same as the cosine of 45 degrees. So that means that the cosine would be the square root of 2 over 2. And that would be the answer, or how you would evaluate a trigonometric function utilizing reference angles. And let's look real quick at the one last example. Let's say I have to look for the sine, or excuse me, I know that the cosine of pi fourths is 45 degrees. And I know that 5 pi over 4, if I look at the unit circle, where 5 pi over 4 lies is in quadrant 3. And because quadrant 3, so I know that the cosine of pi over 4 is the square root of 2 over 2, because the reference angle is pi fourths. But I want to know if that's positive or negative. So there's two ways of knowing that. In your book on page 100 and I believe it's on page 118, is what we have the unit circle, and the unit circle gives us the measurements in angles and in degrees. And 5 pi over 4 is the same thing as saying, or is equal to 225 degrees. And 225 degrees is here in quadrant 3. So remember our acronym of all students take calculus: A, S, T, and C. And That means that if an angle, the terminal side of an angle, be it in radians or degrees, is in quadrant 3, the only positive function is the tangent. So we know that the cosine of 5 pi over 4 is, or excuse me, we know that the reference angle of that 5 pi over 4 in degrees is 225. So that means that the cosine of 5 pi over 4 is actually negative the square root of 2 over 2, because 5 pi over 4, the terminal side, is located in quadrant 3. And let me go over that with you guys real quick, just in case, so that no one is confused. Okay. One thing that we want to determine, or we want to find out, is whether take into account the terminal side and the location of the angles in the terminal side. Okay, so let's look at this real quick. The problem is asking us to find the cosine of 5 pi over 4. So what I'm going to do is I am going to find the reference angle of the radian, because it's a special radian, which it is. So the reference angle is pi over 4. And because pi over 4 is a special radian, I know that pi over 4 is equivalent to 45, and the cosine of 45 is the square root of 2 over 2. So the cosine of pi over 4 is also the square root of 2 over 2. So my answer is not yet finished, because I want to determine if it's positive or if it's negative. So one way of doing that is to take 5 pi over 4 and converting it back to a degree. And let me go ahead and do the process so you guys understand what I did. So what I can do is I can take 5 pi over 4 and convert it into degrees. And that would be, if I'm going from radians to degrees, that would be 180 over 4, or over pi, 180 over pi. And basically what I did, and let me just do the entire process. And what I did is I canceled out pi and pi, and I multiplied 180 times 5 and divided that by 4, and that equaled to 225 degrees. And 225 degrees is in quadrant 3. And in quadrant 3, we know, based on the All Students Take Calculus acronym that we discussed, we know that in quadrant 3, the only positive function is the tangent. And I'm being asked to look for the cosine. So I know that the cosine of 5 pi over 4 is going to be negative square root of 2 over 2, because the terminal side is located in quadrant 3. Okay, so one last time I'm going to review it, then we're going to go and do one more so that we're all clear on this. Okay. The original problem states, or asks me to find the cosine of 5 pi over 4. The reference angle, because pi over 4 is a special radian, is pi fourths. Pi fourths is equivalent to 45 degrees, so the cosine of pi fourth is the square root of 2 over 2. So I know that much. Now I just want to determine if that's going to be positive square root of 2 over 2 or negative. So what I can do is I can take the 5 pi over 4 and convert it into a degrees using the formula that we've already practiced. So that would be 5 pi over 4 equals 180 over pi. Pi signs cancels out. 5 times 180 divided by 4 equals 225 degrees. Because 225 degrees is in quadrant 3, and I know that the only positive function in quadrant 3 is the tangent, I can then determine that the cosine of 5 pi over 4 equals negative square root of 2 over 2 based on the fact where it's located. Now let's look at one last example to clarify, because I know that can be a little confusing. And let's say we're going to look for the sine of 7 pi over 4. So let me go ahead and erase all this. 7 pi over 4. 7 pi over 4. So let me go ahead and erase this real quick so that we can do that. So now we're not looking for the cosine, we're looking for the sine of 7 pi over 4. Okay, let me erase all this. So we're looking for the sine of 7 pi over 4. Now, is pi fourths a special, let me erase this. I know I have to rewrite it again, but either way. Is pi fourths a special radian? Yes, it is. So that means that the reference angle of 7 pi over 4 is pi over 4. And now I can determine if this is true. So I know that the sine of pi fourths is the same thing as the sine of 45. So that means that the sine of pi over 4 equals the square root of 2 over 2. But what I want to know is if it is positive the square root of 2 over 2 or negative. And in order for me to do that, I can memorize the unit circle, or I can just simply convert 7 pi over 4 into degrees, and based on where the angle is located in which quadrant, I can then determine if that answer is going to be positive or negative. So I'm going to go ahead and convert 7 pi over 4 into degrees. Remember that we simply use the formula that says 1 radian is 180 divided by pi. And we're simply going to cancel out the pi signs. And we're going to multiply 180 times 7 and divide that answer by 4. And this time I'm going to be more specific and actually do the process, just because I know that I might have some people who just don't, it's harder for them to see where the numbers came from. So if I multiply 180 times 7, I multiply 180 times 7, that equals 1,260 degrees, or 1,260, excuse me. And now I'm going to divide that answer by 4. And if I divide 1,260 by 4, the answer is going to be 315. So this is going to be 315 degrees. And I know that 315 degrees is in quadrant 4. So that means that the only positive function in quadrant 4 is the cosine. So that means that my answer, that the cosine of 7 pi over 4 is going to be negative square root of 2 over 2. I'm sorry, not the cosine, the sine. The sine of 7 pi over 4, let me write that better. The sine of 7 pi over 4 equals the negative square root of 2 over 2. Okay? The negative square root of 2 over 2. Ladies and gentlemen, hopefully this video will clarify any doubts and help you. If you have any questions, you can always pause and rewind it. Or if you have any questions, you can always find me. So stay safe, and we will see each other in our next class. Bye.